we said that when you dive deep into the ocean, we won't be able to breathe because there will be more pressure, and here we are experiencing atmospheric pressure, and how atmosphere exerts pressure, how a column of liquid exerts pressure. That's what we are trying to understand here. And we will also understand the reason for this. Suppose in a tank, suppose if you are filling it with some water, if you prick a hole here at the bottom, you know that water will spurt out at higher speed. And if you prick a hole here, then the speed will be lesser. And if you prick a hole here, it will be even lesser. So that's what we are trying to understand. If you go deep into this thing, the more the depth, more will be the pressure. That is the reason why in any dam, basically they will build a dam like this. Because when you fill up to this level of water, the bottom exerts, the liquid, the water exerts more pressure at the bottom. That is why for the dam not to be damaged, it has to be built strong at the bottom. So the bottom of a dam is generally more wider than the top, and it has to be constructed very strong also. That's what we are trying to do here. The first thing about this thing, we are trying to understand the pressure due to a liquid column. Suppose you consider a vessel and you fill it with a liquid, and there are 2-3 things we need to understand. First point, pressure. We know that pressure is force by area. That means the thrust acting on 1 meter square area. We are also trying to do this, density. So far we haven't discussed density in any video. Just know that density is nothing but mass of 1 meter cube volume of a substance. So because if you write pressure as force by area, the area's unit is meter square, then 1 meter square area the force acting is called pressure. Suppose if you write density as mass by volume, then the unit of volume is meter cube. The mass of 1 meter cube volume is called density. If density is mass by volume, if you cross multiply, density into volume is mass. So that we are going to use here. So mass is the product of density and volume. So the density is referred by the letter Greek alphabet rho. It's kind of P, so we will pronounce this as rho. So the density into volume. Mass of a substance is density into volume of the substance. Suppose you are filling it with a liquid. Generally heavier liquids have more density, lighter liquids have less density. Suppose you have a tank. In the tank you fill it with a liquid, and the density of the liquid is rho. You would like to know that from the top surface, this is the surface of the tank. From here, if you do a point, you consider a point here. At this point, what is the pressure? At all points here, since they are at the same depth, they all have the same pressure. That's what we studied. Pressure at a particular depth are all same. That we know experimentally. So empirically. So if you want to find out pressure due to this liquid of density rho at a depth, because from the top surface, if you go dive, if you deep down, this is called depth. So let us call from this point to this point, this distance is h. So at a depth h, at this point, what is the pressure? At every point at this depth, pressure is the same, because that is a property of a liquid. And you consider an area, a circular area you consider. Okay, then this circular area is considered at this depth. All the points on this circular area, same pressure they will have. So who is going to exert pressure on this? Above this area, there is a column of liquid. So this liquid above this area is applying its weight on the area. So we know that pressure is force per area, force per unit area. Here force is exerted by weight of this liquid column on this area. So pressure at this point, which is at a depth h, is weight of the liquid above that depth by area. Suppose this circular area having a value a, then this cylinder, because above the circular area, if you project it, it will be a cylinder. The area of the, volume of the cylinder equal to pi r square h. If you assume this area as A, so this pi r square is the area, base area into height. So volume of any object can be written as area into height except for the sphere. So it is volume is area into height. Here pressure is weight of the liquid by area. In our first discussion about weight, we said that weight is nothing but the product of mass and gravity. Wherever you keep the cylinder, this vessel, the gravity at this point, let us say G, then the weight of this liquid column on this surface is mass into gravity, then by area. From this, mass is a product of density into volume. We'll be writing this mass as density into volume into gravity by area. Then density into volume. So this volume of this cylinder is area into height. So area into height into gravity by this area into height. So it is area into height by area. So when you cancel this, the pressure due to a liquid column has come about H rho G. H rho G. Or you can even say it as rho G H. It has got lots of implications. We'll be talking about it in the subsequent video. But here you see that pressure is rho G H. Whether it works, whether it agrees according to the unit, we'll see to it. Pressure is density, gravity, height or depth. Here we should call it depth. So pressure due to a liquid column is rho GH. Then rho should be in kilogram per meter cube, because unit of density is unit of mass by volume. Mass is in kilogram, volume is in meter cube. Kilogram by meter cube. So the unit of density is kilogram by meter cube. Suppose if you want to find the pressure in SI system, the height should be substituted in meters and density should be substituted in kilogram per meter cube and gravity must be substituted in meter per second square. Suppose atmospheric pressure generally is 1 lakh pascals, that you know, that we will discuss in the subsequent video. And if you go just 100 meter or 10 meters into the ocean deep, 10 meter deep, 10 meter deep if you go, at the surface atmospheric pressure is 1 lakh pascals approximately. We'll also discuss about this. And if you go 10 meter deep, here at this pressure due to liquid column is rho GH. The density of water is 1000 kilogram per meter cube and gravity value is approximately 10 meter per second square. We discussed about it. Then here the pressure due to this 10 meter liquid column into the ocean is rho GH. Rho GH. Rho value for water is approximately 1000 and gravity value is 10. The depth you are going is just 10. So you are getting 1 lakh pascals. 1 lakh pascals. If you go just 10 meter into the ocean, you experience double the pressure that you experience at the top. If you go 20 meters, you will experience thrice the pressure at the bottom. So every 10 meter, if you go down, you experience double, triple, 4 times the pressure. So every 10 meter, your pressure is actually increasing by 1 lakh pascals into the ocean. That's why beyond certain depth, we won't be able to dive in. Without proper oxygen cylinders, that is mixed with some other gas, nitrogen per se, so you won't be able to breathe even with oxygen cylinders, because when you want to breathe, you have to expand your lungs. But the pressure is so strong, that so high that you won't be able to breathe in. So that is the danger even if you carry an oxygen cylinder into the ocean. So we'll discuss the other things in the other videos.